becomes an enormous ocean when it stretches across millions of light years. Gravity quietly works upon this invisible sea. Dark matter halos surrounding galaxies create gentle valleys in the gravitational landscape. Hydrogen slowly begins drifting toward those valleys, not rushing, not collapsing all at once, simply flowing, patiently, like rainwater finding the lowest point in a quiet field. Astronomers often describe this process as gas accretion. Cold hydrogen from intergalactic space gradually falls into galaxies over immense periods of time. Some arrives through narrow filaments of the cosmic web, the enormous invisible network connecting galaxies across the observable universe. These filaments behave almost like rivers, not rivers of liquid, but rivers of atoms. Ancient hydrogen begins a journey that may last billions of years before finally reaching a galactic disk. There, something extraordinary happens. As the gas accumulates, gravity gently squeezes enormous clouds together. The clouds cool, they become denser. Within their quiet interiors, tiny regions begin collapsing even further. Eventually, temperatures rise high enough for nuclear fusion to ignite. A new star is born. Its first light appears only after a journey that began across the darkness long before our own solar system existed. In a sense, every newborn star has been traveling toward its birthplace for billions of years. Modern telescopes have even begun observing these invisible rivers directly. Using distant quasars as brilliant background beacons, astronomers detect delicate fingerprints left by hydrogen drifting through intergalactic space. The gas itself remains almost invisible, but it quietly absorbs tiny portions of the quasar's light. Those missing wavelengths reveal enormous streams flowing toward galaxies. It is a beautiful form of detective work. The rain cannot be seen directly, only the faint traces it leaves behind. Computer simulations paint an even more breathtaking picture. Rather than isolated islands, galaxies appear connected by graceful filaments stretching across hundreds of millions of light years. Fresh hydrogen continuously glides along these invisible pathways. Some astronomers affectionately call them cold flows. The name feels wonderfully appropriate. Not violent, not explosive, simply gentle streams carrying tomorrow's stars. Yet galaxies do not only receive, they also give back. When massive stars explode as supernovae, powerful winds push gas outward into surrounding space. Supermassive black holes can launch enormous outflows that carry enriched material far beyond a galaxy's visible edge. At first, this seems wasteful. Why throw away precious fuel? Nature, however, prefers recycling. Much of that expelled gas eventually cools. Some drifts into the galactic halo. Some mixes with the intergalactic medium. Over immense stretches of time, gravity may pull portions of it back once again. The rain never truly stops. The same hydrogen may participate in several generations of stars before its journey finally ends. The atoms inside our own bodies almost certainly experienced similar adventures. The hydrogen within every drop of water you have ever touched was born shortly after the Big Bang. Some of it wandered through intergalactic space for billions of years. Some passed through ancient stars that no longer exist. Some drifted inside invisible rivers between galaxies before eventually becoming part of the cloud that formed our sun. Even now, those ancient atoms continue their endless cycle through the cosmos. Perhaps there is something deeply comforting about that. Nothing in the universe seems truly isolated. Galaxies depend upon invisible rivers they can never fully see. Stars rely upon hydrogen that began its journey unimaginably far away. Planets inherit the ashes of older suns. Life itself grows from atoms that have wandered across cosmic oceans since nearly the beginning of time. The universe survives because it keeps sharing. Its greatest creations are rarely built from brand new materials. Instead, they emerge from ancient gifts, patiently passed from one generation to the next. A newborn star is never truly new. It is simply the latest chapter in a story billions of years old. Perhaps that is why the night sky feels so timeless. Every bright star above us is both an ending and a beginning, a destination and another departure. Its light reminds us that creation rarely arrives all at once. It comes quietly, drop by drop, atom by atom, across distances so vast that patience itself becomes part of the process. And somewhere tonight, far beyond the glowing edge of the Milky Way, invisible streams of ancient hydrogen continue drifting silently through the darkness, crossing the hidden rivers of the cosmic web, falling gently toward galaxies that have not yet finished growing, preparing clouds that have not yet become stars, carrying tomorrow's sunrise across an ocean that has been flowing since almost the beginning of time. If these quiet journeys through the universe help you relax before sleep, consider subscribing so we can continue uncovering its peaceful mysteries together. 4. The slow dance, older than every ocean. Long before Earth had oceans, entire galaxies had already begun graceful dances that are still continuing tonight. Imagine standing in an enormous ballroom. The music is so soft that you can barely hear it. The dancers move so slowly that, after watching for an entire minute, you aren't even sure they've changed position. It almost feels as though time itself has stopped. But if you could return 1,000 years later, you would discover that every couple had crossed the room. Their paths had intertwined. Some partners had separated. Others had met for the very first time. The dance had never paused. It simply unfolded far too slowly for a single lifetime to notice. The universe is filled with dances like these, not performed by people, but by galaxies. Long before the Earth possessed its first oceans, before continents drifted across our planet, before the earliest cells learned how to divide, entire galaxies had already begun graceful journeys around one another. Some of those dances continue even now. Every telescope that looks into the deep universe captures only a single frozen step in performances that last billions of years. Tonight, we'll slow ourselves to the rhythm of the cosmos. We'll discover why galaxies almost never travel alone, how gravity becomes the quiet music guiding every movement, and why the elegant dance unfolding above us tonight began long before our own world was ready to witness it. When we picture galaxies, we often imagine them as permanent islands, magnificent spirals quietly floating through endless darkness, each one complete, each one independent. The truth is far more beautiful. Galaxies are travelers. Every one of them moves. Some drift gently through space. Others orbit inside enormous galaxy clusters. Many slowly approach companions they will eventually embrace. The night sky appears peaceful, not because nothing moves, but because everything moves with extraordinary patience. Consider our nearest large galactic neighbor. The Andromeda Galaxy lies about 2.5 million light-years away. To our eyes, it seems perfectly still. Night after night, year after year, its graceful spiral shape never changes. Yet appearances can be wonderfully deceptive. Andromeda is moving toward us at roughly 100 kilometers every second. Every minute, it comes closer. Every hour, the distance shrinks slightly more. Of course, the gap between us is so enormous that these changes remain impossible for human eyes to notice. Even after your entire lifetime, Andromeda will appear almost exactly where it does tonight. But give the universe another 4 to 5 billion years, and something extraordinary will happen. The Milky Way and Andromeda will meet, not in a violent crash like two speeding cars, but in one of the grandest dances the cosmos has ever choreographed. Imagine two clouds of glowing fireflies drifting gently toward one another. Most of the individual insects never collide. Instead, they weave through one another in slow, elegant patterns. Galaxies behave in much the same way. Although each contains hundreds of billions of stars, the distances separating those stars are so immense that direct collisions between individual suns are remarkably unlikely. Instead, gravity reshapes the galaxies themselves. Their spiral arms stretch into long luminous ribbons. Stars are gently redirected into new orbits. Great streams of gas twist through the darkness like ribbons caught in a slow breeze. For hundreds of millions of years, the two galaxies will circle one another, passing, returning, passing again, each encounter drawing them closer. Eventually, their graceful spiral forms will dissolve into a single giant elliptical galaxy. Astronomers sometimes call this future home Milkomeda. The dance ends, not because either partner disappears, but because together they become something entirely new. Yet Andromeda is only one dancer among countless others. Throughout the observable universe, galaxies rarely remain completely alone. Many belong to families known as galaxy groups. Our own local group contains more than 50 known galaxies. Some are majestic spirals, others are tiny dwarf galaxies, quietly orbiting larger companions. Gravity binds them together across millions of light years. Each follows its own patient path. Some of these small galaxies have already completed several orbits around the Milky Way. Others are only now beginning their approach. The choreography never truly repeats. Every journey becomes unique. Move outward to even larger scales, and the dance grows more magnificent still. Galaxy clusters contain hundreds, sometimes thousands, of galaxies moving together through enormous halos of dark matter. Imagine watching a flock of birds from far above. Each bird follows its own path, yet together they create flowing patterns that no single bird could produce alone. Clusters behave similarly. Every galaxy responds not only to its nearest neighbors, but also to the collective gravity of the entire group. No conductor waves a baton, no one gives instructions. Gravity alone composes the music. Perhaps the most famous cosmic dance occurs inside the antennae galaxies. These two spiral galaxies are caught in the middle of a spectacular merger. Their graceful arms have stretched into enormous arcs, reaching far into space. Bright clusters of newborn stars ignite where clouds of gas collide and compress. Seen through powerful telescopes, the scene resembles two dancers whose flowing robes have become intertwined. Although the image captures only a single instant, the performance itself spans hundreds of millions of years. We happen to witness one beautiful step. Elsewhere, astronomers have observed delicate tidal tails extending hundreds of thousands of light years from merging galaxies. These glowing streams contain stars gently pulled away by gravity during close encounters. Nothing is wasted. Some of those wandering stars eventually settle into new galaxies. Others drift through intergalactic space for billions of years. Even separation becomes part of the choreography. There is another fascinating consequence of these ancient dances. Galactic collisions often trigger entirely new generations of stars. As enormous clouds of hydrogen pass through one another, gravity compresses the gas until stellar nurseries awaken. Thousands, sometimes millions, of new suns burst into existence. What first appeared to be destruction quietly becomes creation. Nature rarely chooses one without the other. Every ending prepares another beginning. The Milky Way itself carries evidence of countless past dances. Astronomers have discovered long streams of stars arching across our galaxy. These stellar rivers are the remnants of smaller galaxies slowly pulled apart during ancient encounters. Their original homes no longer exist. Yet, their stars continue circling the Milky Way, preserving silent memories of dances completed billions of years ago. Even our galaxy's thick disk and halo contain clues suggesting that mergers shaped much of its history. The Milky Way we admire tonight is not the galaxy that first formed long ago. It is the result of countless graceful meetings spread across cosmic time. There is something deeply comforting about this. On Earth, we often associate collisions with violence. The universe teaches a gentler lesson. Its greatest transformations usually happen slowly, patiently, beautifully. Galaxies approach one another for billions of years before finally merging. They do not rush. They do not resist the rhythm written by gravity. Instead, they surrender to it. Every orbit, every close encounter, every graceful curve through space becomes another note in an ancient melody that began long before oceans shimmered beneath Earth's first skies. Perhaps that is why the universe feels so peaceful when viewed across immense spans of time. What appears chaotic in a single moment often becomes breathtakingly elegant when seen across billions of years. The dance has always been beautiful. We simply live during one tiny step. And somewhere tonight, beyond the familiar constellations above our world, two ancient galaxies continue circling one another through the darkness. Their stars glowing like countless lanterns inside a silent ballroom, their invisible paths guided by gravity alone, still dancing, as they have since before Earth knew rain, before oceans reflected sunlight, before life itself had begun dreaming beneath the stars. 5. The light hidden inside darkness. Some of the brightest chapters of cosmic history may have unfolded inside places where almost no visible light could escape. Imagine standing outside a Greek cathedral late at night. Its enormous stone walls hide everything within. The windows are dark. The heavy doors remain closed. From the outside, it appears completely silent. You might assume nothing is happening inside. But beyond those ancient walls, candles may still be burning. Choirs may still be singing. People may still be gathering beneath towering ceilings invisible from where you stand. The greatest activity is hidden, not because it does not exist, but because you simply cannot see it. The universe is filled with places like that. For generations, astronomers believed that the brightest moments in cosmic history must also be the easiest to observe. Surely the birth of countless stars would fill the heavens with brilliant light. Surely galaxies growing at extraordinary speeds would shine across the universe like celestial beacons. Yet modern astronomy has revealed something wonderfully surprising. Some of the most productive periods of star formation happened inside enormous clouds of dust so thick that visible light could barely escape. Entire generations of stars were born behind curtains of darkness. From Earth, these galaxies appeared strangely dim, almost invisible. Yet hidden inside them were some of the brightest chapters the universe has ever written. Tonight, we'll step beyond the visible sky. We'll discover why darkness sometimes protects creation instead of hiding it, how invisible galaxies transformed the young universe, and why some of the brightest lights in existence first learned to shine where no ordinary eye could ever see them. Human beings naturally trust their eyes. When something glows brightly, we assume it must be important. When something disappears into shadow, we often overlook it. Our ancestors navigated forests by sunlight. They crossed oceans using the stars. Vision became our most reliable guide. But the universe gently reminds us that light tells only part of the story. Sometimes, the most remarkable things happen where visible light cannot travel. Dust is responsible for much of this hidden world. On Earth, dust feels insignificant. A thin layer settles quietly upon forgotten books. Sunlight reveals tiny particles drifting through open windows. We wipe it away without much thought. Cosmic dust, however, is very different. Although each individual grain is incredibly small, often no larger than particles in cigarette smoke or fine sand, it fills enormous regions of space. These tiny grains contain carbon, silicon, oxygen, and other heavy elements forged inside ancient stars. Every grain is a gift from earlier generations of suns. When enough of this dust gathers together, something extraordinary happens. Visible light begins to disappear. Imagine driving through an exceptionally thick fog. Nearby trees slowly fade, mountains vanish completely. The landscape still exists. Only your ability to see it has changed. Dust behaves much the same way. It scatters and absorbs visible light traveling through space. Entire stellar nurseries become hidden behind enormous veils. To ordinary telescopes, these regions appear strangely dark. Yet darkness does not mean emptiness. Quite the opposite. Inside these dusty clouds, gravity quietly continues its work. Hydrogen gathers, temperatures slowly rise. New stars begin forming one after another. Each newborn sun illuminates its surroundings. But its visible light rarely escapes very far before meeting another curtain of dust. The galaxy glows brilliantly, yet only from the inside. Astronomers call many of these remarkable systems dusty starburst galaxies. The name sounds dramatic because their activity truly is extraordinary. Some create hundreds, even thousands, of new stars every single year. For comparison, our own Milky Way forms only a few new stars annually. Imagine a quiet village where only 1 or 2 homes are built each year. Now compare it with a rapidly expanding city where hundreds of buildings rise almost simultaneously. That difference hints at the astonishing pace inside starburst galaxies. One famous example is ARP 220. Located roughly 250 million light-years away, it appears relatively unremarkable in visible light. But observe it using infrared telescopes, and an entirely different universe emerges. Its hidden interior blazes with intense star formation. 2 galaxies collided long ago, compressing enormous clouds of gas and dust. That collision ignited one of the brightest hidden stellar factories astronomers have ever observed. The light was always there. Only the dust concealed it. This realization transformed astronomy. For much of history, telescopes observed primarily visible light. But visible light represents only a tiny fraction of the universe's full spectrum. Infrared radiation tells another story. Dust that blocks visible light absorbs its energy. Then, very gently, it releases that energy again as infrared light. Instead of disappearing, the hidden light simply changes its language. Modern observatories like the James Webb Space Telescope were designed partly to understand this invisible universe. Unlike the human eye, Webb sees infrared wavelengths remarkably well. Where older telescopes found darkness, Webb discovers glowing clouds, hidden galaxies, and stellar nurseries previously concealed for billions of years. It is rather like switching from ordinary eyesight to thermal vision. The landscape suddenly fills with life that had always been present. Some of the earliest galaxies discovered by Webb appear surprisingly mature. Many contain large amounts of dust, even though the universe was still relatively young. This puzzled astronomers. Heavy elements needed to create dust originate inside stars. How could so much dust already exist? The answer suggests that early galaxies formed stars with astonishing speed. Entire generations of massive stars lived, died, and enriched the universe far earlier than scientists once expected. The brightest chapters of cosmic history unfolded rapidly, hidden behind their own creations. There is something beautifully poetic about that. Stars create the very dust that later hides future generations of stars. Creation protects creation. One generation quietly shelters the next. The universe often behaves less like a machine and more like an ancient forest. Fallen leaves nourish the soil. The soil feeds new trees. The new trees someday become forests that shelter future life. Nothing is wasted. Everything participates. Dust performs another remarkable role. Without it, planets like Earth might never exist. Tiny dust grains drifting through young stellar disks slowly collide. They stick together. Pebbles become rocks. Rocks become mountain-sized bodies. Eventually, entire planets emerge. The dust that once hid newborn stars eventually becomes worlds capable of oceans, mountains, and perhaps curious beings who wonder where they came from. In a very real sense, our own planet began as invisible dust floating inside darkness. Even our bodies preserve this quiet history. The carbon in every living cell, the silicon beneath every mountain, the oxygen we breathe, all were once hidden inside ancient dusty clouds where visible light struggled to escape. We are, quite literally, children of invisible places. Perhaps that is one of the universe's gentlest lessons. Not everything important needs to be seen immediately. Seeds germinate beneath soil. Babies grow safely within the womb. Butterflies transform inside silent cocoons. Entire galaxies spend millions of years creating new stars behind veils of dust. Nature rarely rushes its greatest masterpieces into the light. It allows them to mature quietly first. The night sky encourages us to do the same. Every dark cloud between the stars may conceal future suns. Every hidden galaxy may preserve another forgotten chapter of cosmic history. Every region that appears empty may simply be waiting for another way of seeing. Sometimes, darkness is not the absence of light. It is the place where light is still becoming. And somewhere tonight, beyond the reach of ordinary telescopes, a galaxy wrapped in ancient dust continues giving birth to thousands of brilliant new stars, its hidden nurseries glowing softly in invisible, infrared light. Its brightest stories unfolding behind curtains no human eye can ever fully penetrate, patiently proving that some of the greatest lights in the universe first learn to shine inside the deepest darkness. 6. The stars that never met another sun. Some lonely stars may have spent billions of years shining in complete isolation, never once passing close to another stellar neighbor. Imagine lighting a single lantern in the middle of an endless desert. No villages lie beyond the dunes. No distant campfires flicker on the horizon. No roads connect your lonely light to another traveler. Night after night, the lantern burns exactly where it has always stood. Its flame dances gently in the silent wind. Yet no one ever passes close enough to see it. Years become centuries. Centuries become millennia. Still, the lantern patiently continues shining into an emptiness that seems almost infinite. The universe may contain stars like this. When we picture the night sky, we naturally imagine stars living together. They gather inside graceful spiral galaxies. They fill brilliant star clusters. They orbit companions in elegant binary systems. Even our own sun belongs to a galaxy containing hundreds of billions of stellar neighbors. It is easy to believe that every star enjoys similar company. But the universe is far larger and far lonelier than our instincts allow us to imagine. Some stars may have spent billions of years drifting through the darkness between galaxies, so isolated that they never once passed near another sun. No neighboring constellations, no crowded stellar skies, only endless blackness stretching in every direction. Tonight, we'll journey into these forgotten regions between the galaxies. We'll discover how stars can lose the homes where they were born, why gravity sometimes sends them wandering forever, and how even the loneliest lights in existence continue carrying quiet stories across the deepest oceans of space. Loneliness is usually something we measure by distance. 2 houses separated by a field do not seem lonely. 2 islands separated by an ocean begin to feel isolated. But what if the nearest neighbor lay millions of light years away? That is the extraordinary scale of intergalactic space. Galaxies themselves are immense. The Milky Way stretches roughly 100,000 light years across. Within it, stars are separated by astonishing distances, yet they still belong to the same great family. Outside the galaxy, however, the emptiness grows almost unimaginable. Between the Milky Way and the Andromeda Galaxy lies roughly 2.5 million light-years of mostly empty space. If a lone star found itself drifting across that enormous gulf, billions of years might pass before it ever approached another galactic home. The journey would outlast continents. It would outlast oceans. It might even outlast civilizations not yet imagined. How could such a lonely traveler come to exist? The answer begins with gravity. Gravity is often gentle. It gathers stars into galaxies. It binds planets around suns. It holds galaxies inside enormous clusters. Yet, under certain circumstances, gravity can also become a master of escape. Imagine children spinning one another around on a playground carousel. Most continue circling happily together. But if one child lets go at exactly the right moment, they fly outward into the open field, not because someone pushed them away, but because motion carried them beyond the group. Stars can experience something surprisingly similar. Inside crowded galaxies, close gravitational encounters occasionally occur. A passing dwarf galaxy tugs upon another. Massive black holes alter stellar orbits. Clusters of stars interact like dancers, briefly changing partners. Most stars remain safely bound. A very small number receive just enough additional speed to escape their galaxy altogether. Astronomers call some of these remarkable travelers hypervelocity stars. They move so rapidly that even the immense gravity of the Milky Way cannot pull them back. One of the most dramatic ways to create such a star involves the supermassive black hole at the center of our galaxy. Imagine a binary star system, two suns peacefully orbiting one another. If they wander too close to the central black hole, gravity performs an extraordinary trick. One star may be captured. Its companion receives an enormous gravitational slingshot. Suddenly, it races outward at millions of kilometers per hour, fast enough to escape the galaxy forever. Its peaceful home disappears behind it. Ahead lies only darkness. Another pathway into loneliness occurs during galactic collisions. As we discovered in our previous journey, galaxies constantly dance across the universe. Sometimes those dances become embraces. When two galaxies merge, enormous tidal forces stretch long streams of stars far beyond their original homes. Many eventually settle inside the new galaxy. Others never return. They continue drifting through intergalactic space, carrying only the memory of where they began. Imagine autumn leaves blown from an ancient forest. Most fall nearby. A few catch powerful winds and travel astonishing distances before finally coming to rest. Stars can become cosmic leaves. There are also stars born inside tiny dwarf galaxies that later disappear entirely. Large galaxies, like the Milky Way, gradually pull these smaller companions apart. Their stars scatter into enormous streams, wrapping around the larger galaxy. Occasionally, some continue drifting outward until they no longer belong clearly to either system. Their original neighborhood has vanished. Their future destination remains uncertain. Modern astronomy has discovered evidence that these lonely wanderers truly exist. Observations of galaxy clusters reveal faint populations of intergalactic stars, sometimes called intracluster stars. These suns no longer orbit any single galaxy. Instead, they travel through the vast gravitational field shared by the entire cluster. Seen from one of their hypothetical planets, the night sky would appear astonishingly different. A magnificent galaxy might glow faintly on one horizon. Another distant island of stars could shimmer far away in another direction. Yet nearby stellar neighbors would be almost entirely absent. Darkness would dominate everything. Would planets be able to survive around such isolated stars? Remarkably, yes. Gravity does not care whether a star lives inside a galaxy or between galaxies. If planets formed before the star escaped, or under certain rare conditions afterward, they could continue orbiting peacefully. Imagine standing upon such a world. There would still be mornings, still be sunsets, still be seasons if the planet tilted gently upon its axis. Life beneath your own sun could continue almost normally. Only the night would reveal your extraordinary isolation. No broad river of the Milky Way stretching overhead. No bright neighboring stars forming familiar constellations. Only your own quiet sun surrounded by an ocean of darkness, almost impossible to comprehend. Perhaps the nearest visible galaxy would resemble a soft glowing cloud rather than a sky filled with countless individual stars. The universe would feel wonderfully peaceful and profoundly lonely. Yet loneliness does not mean purposelessness. Every wandering star carries something precious. Inside its core, hydrogen continues becoming helium. Later generations of heavier elements quietly form. If that star eventually reaches the end of its life, it may enrich completely new regions of intergalactic space. Its journey contributes to places no other star could ever reach. Even alone, it continues participating in the universe's endless cycle of creation. There is something deeply comforting about that idea. We often imagine belonging as remaining exactly where we began. Nature quietly suggests another possibility. Sometimes belonging means carrying your light with you, no matter how far you travel, no matter how empty the road becomes. A wandering star never stops being a star simply because it leaves home. Its purpose remains unchanged. Its light continues shining. Its warmth continues flowing outward into the darkness. Perhaps we are not so different. Our lives carry us far from familiar places. Friends move away. Families grow. New chapters begin. Old neighborhoods become memories. Yet something essential travels with us. The quiet light we have gathered through every earlier season. The universe seems to understand this gentle truth. Its loneliest stars are never truly abandoned. They remain connected by the same laws of gravity, forged from the same ancient hydrogen, sharing the same cosmic history as every brilliant sun still resting inside crowded galaxies. Distance changes perspective. It does not erase belonging. And somewhere tonight, far beyond the glowing edge of any familiar galaxy, a solitary star continues crossing an ocean of darkness, its tiny family of planets perhaps still circling faithfully around it, its warm light spilling into emptiness that no other nearby sun has touched for billions of years, patiently proving that even the loneliest traveler in the universe can still carry an entire sunrise wherever it goes. 7. The first quiet architects of the cosmos. Before the first galaxy ever existed, invisible forces had already begun arranging where every future star would eventually belong. Imagine arriving at a magnificent city just as the morning sun begins to rise. Towering buildings stretch toward the sky. Bridges connect distant neighborhoods. Tree-lined streets wind gracefully between parks and quiet squares. Everything appears so carefully arranged that it feels impossible to believe it happened by chance. Yet, if you had visited this same place centuries earlier, you would have found only empty fields. No houses, no roads, no towers touching the clouds. What existed instead were invisible plans, surveyors quietly placing markers into the earth, builders measuring distances no one else could yet understand. Long before the first stone was ever laid, the shape of the future city had already begun to exist. The universe may have experienced something remarkably similar. Long before the first galaxy illuminated the darkness, before the first star ignited, before planets, oceans, or life had even the smallest possibility of existing, invisible forces were already patiently arranging the future. Tiny fluctuations in the young universe, far too small for any eye to see, became the first quiet architects of everything that would eventually follow. Every spiral galaxy, every glowing nebula, every sun, even the atoms that would someday become you. Tonight, we'll travel back to an age before there were galaxies to admire. We'll discover how gravity began designing the universe while almost nothing yet existed. why invisible dark matter became the foundation beneath every future star, and how the greatest construction project in cosmic history unfolded without noise, light, or anyone there to witness it. When we think about creation, we often imagine dramatic beginnings, lightning flashes. Mountains erupt, stars explode into brilliant existence. Nature certainly knows how to be spectacular. But some of its greatest achievements begin almost silently. A forest starts with a seed. A coral reef grows one tiny skeleton at a time. A snowflake forms from microscopic crystals, drifting quietly through cold air. The universe follows that same patient rhythm. Its greatest masterpiece was never built all at once. It emerged gradually, piece by piece, over billions of years. To understand those first architects, we must travel back almost 14 billion years, shortly after the Big Bang. At that time, the universe was astonishingly young. There were no galaxies, no stars, no planets, only an expanding sea of energy slowly cooling into simple particles. Hydrogen and helium became the dominant ingredients of everything that would later exist. If you could somehow observe this ancient cosmos from a safe distance, it might appear surprisingly smooth, almost featureless. Yet, hidden within that smoothness were incredibly tiny differences. Some regions contained just a little more matter than others. The variations were astonishingly small. In many places, the difference amounted to only 1 part in 100,000. To human intuition, such tiny irregularities seem almost meaningless. But gravity is extraordinarily patient. It never asks whether a difference is large, only whether one exists. Over millions, then hundreds of millions, then billions of years, those tiny advantages slowly grew. Regions containing slightly more matter attracted even more material. As they became heavier, their gravity strengthened. That stronger gravity gathered still more matter. The process fed itself continuously. Astronomers often compare it to rolling a small snowball down a snowy hill. It begins almost unnoticed. But as more snow collects, the snowball grows larger. Its growth accelerates naturally. The universe's first structures formed through exactly this kind of quiet accumulation. Yet something even more mysterious participated. Long before ordinary matter began gathering efficiently, invisible dark matter had already taken the lead. Although dark matter neither emits nor reflects light, its gravity profoundly influences everything around it. Think of building a great cathedral before stained glass windows are installed, before marble floors are polished, before the towering roof reaches toward the sky. Builders first create a hidden framework, steel beams, stone foundations, support columns buried beneath the finished walls. Visitors rarely notice these structures. Yet, without them, the cathedral could never stand. Dark matter became the universe's hidden foundation. It gathered into enormous halos long before visible galaxies existed. Ordinary hydrogen slowly flowed toward these invisible gravitational valleys. Without ever seeing the framework, the gas naturally followed it. Eventually, clouds became dense enough for the first stars to ignite. Galaxies appeared. The architecture became visible, but its hidden foundation had already existed for hundreds of millions of years. Computer simulations reveal this astonishing process with breathtaking clarity. When scientists modeled the early universe using the known laws of physics, an intricate network gradually appears. Filaments stretch across space. Huge intersections emerge. Between them, enormous voids quietly expand. The resulting pattern closely resembles the cosmic web observed through modern telescopes today. The resemblance is extraordinary. Tiny fluctuations became enormous structures. Invisible mathematics became visible beauty. One of the most remarkable discoveries came from studying the cosmic microwave background. This ancient radiation represents the oldest light we can observe, released about 380,000 years after the Big Bang. it appears almost perfectly uniform. Yet, hidden within it are incredibly delicate temperature variations. These tiny ripples reveal where matter was ever so slightly denser. In a sense, the universe left behind its original blueprint. Every future galaxy began as one of those faint ripples. It is astonishing to realize that the magnificent spiral galaxies decorating tonight's sky can trace their ancestry back to fluctuations smaller than 1,000th of 1%. Nature rarely requires dramatic beginnings. Patience often proves more powerful. The first stars eventually ignited inside these growing dark matter halos. Their brilliant light transformed the young universe. They created heavier elements. They illuminated surrounding hydrogen. They began the long process that would eventually lead to galaxies like our own Milky Way. Yet none of those later triumphs erased the quiet work of the original architects. Even today, galaxies continue following the invisible framework established near the beginning of cosmic time. Modern observations reveal that galaxies gather along filaments precisely where dark matter predicts they should. Clusters form at the intersections. Immense voids separate them. The architecture remains. Only the decorations have changed. There is something deeply reassuring about this. We often imagine foundations as temporary, something useful only until the visible structure appears. The universe teaches a gentler lesson. Its foundations never disappear. They continue quietly supporting everything that follows. Perhaps our own lives unfold in much the same way. The habits learned during childhood, the kindness offered by strangers, the quiet encouragement of a teacher, the patient love of family. These early influences often become invisible with time. Yet, they continue shaping every future decision long after we stop noticing them. The strongest parts of our lives are often hidden beneath the surface, just as the strongest parts of the universe remain invisible. Gravity never demands attention. Dark matter never seeks applause. Neither shines brightly across the night sky. Yet together they built nearly everything we admire. Perhaps that is why the cosmos feels so peaceful. Its greatest architects worked without recognition, without urgency, without noise. They simply continued doing what gravity has always done: gathering, guiding, building, one atom at a time, 1 million years at a time, 1 billion years at a time. And somewhere tonight, far beyond every familiar constellation, invisible rivers of dark matter still stretch across the universe, quietly holding galaxies in place, guiding new clouds of hydrogen toward future stars, continuing a construction project that began before the first sunrise ever illuminated the cosmos, patiently reminding us that the greatest masterpieces are often designed long before anyone realizes they are being built. If you're enjoying these relaxing stories from across the cosmos, subscribing helps us continue exploring one peaceful mystery at a time. 8. The oceans floating above. Every galaxy drifts inside an invisible ocean so enormous that its waves can stretch across millions of light years. Imagine standing on a quiet cliff overlooking the sea at sunset. The waves below seem endless. Some are small enough to disappear against the shoreline. Others travel across the entire horizon before gently breaking upon distant rocks. You cannot see where every wave began, nor can you predict exactly where each one will end. Yet beneath them all lies one immense ocean, connecting every coastline, every island, and every distant shore into a single living world. The universe may possess oceans like these, not oceans made of water, but oceans of unimaginably hot gas, invisible seas so vast that entire galaxies drift within them, like islands floating across a silent cosmic sea. For most of human history, we never realized these oceans existed. They emit almost no visible light. No telescope pointed toward the night sky could reveal their hidden waves. The galaxies seemed to float through empty space, but space was never truly empty. Above every spiral galaxy, beyond every glowing cluster of stars, stretch enormous reservoirs of ancient gas, heated to millions of degrees and spread across distances so immense that even light requires millions of years to cross them. Tonight, we'll sail across these invisible oceans. We'll discover why galaxies are never truly alone, how these hidden seas quietly shape the growth of cosmic civilizations, and why the largest oceans in existence remain completely invisible to human eyes. When we imagine oceans, we usually picture blue water stretching toward a distant horizon. Life flourishes beneath its surface. Currents transport warmth across continents. Storms rise and disappear. The ocean quietly influences everything around it. Earth's seas regulate our climate. They shape coastlines. They carry nutrients across enormous distances. Without them, life on our planet would look completely different. The universe has found its own version of this remarkable balance. Only instead of water, its oceans are made from plasma. Plasma is often called the fourth state of matter. If ice melts, it becomes liquid. Heat the liquid further, and it becomes gas. Raise the temperature even higher, millions of degrees, and atoms begin losing their electrons. The result is plasma, an extraordinarily hot, electrically charged gas, unlike anything we encounter in everyday life. Surprisingly, plasma is the most common form of ordinary matter in the universe. Stars are made of it. Lightning briefly creates it. The glowing solar wind flowing outward from our sun consists almost entirely of plasma. Yet the largest collections of plasma do not exist inside stars. They surround entire galaxies. To understand these invisible oceans, we must first visit one of the universe's greatest gatherings, a galaxy cluster. Unlike our relatively small local group, galaxy clusters contain hundreds, sometimes thousands, of galaxies bound together by gravity. Imagine looking down upon an archipelago containing thousands of islands scattered across a vast sea. Each island possesses its own forests, rivers, and mountains, yet all of them share the same surrounding ocean. Galaxy clusters behave in much the same way. Each galaxy carries billions of stars, but together they float inside one enormous atmosphere of superheated plasma. This gas becomes so incredibly hot, often exceeding 10 million degrees Celsius, that it no longer emits ordinary visible light. Instead, it shines primarily in X-rays. Human eyes cannot detect these wavelengths. For centuries, these oceans remained completely hidden. Only when powerful space telescopes like Chandra and XMM Newton began observing the universe in X-rays did astronomers realize what had been surrounding galaxies all along. Suddenly, apparently empty regions burst into view, where visible telescopes showed darkness. X-ray observatories revealed glowing seas stretching across millions of light years. Some galaxy clusters contain more hot gas than all of their galaxies combined. That realization surprised astronomers. We tend to think galaxies dominate the universe. In reality, the visible stars inside galaxies account for only a small fraction of ordinary matter. Much of the rest quietly floats around them inside these invisible oceans. Imagine discovering that every island on Earth contains only a small portion of the planet's water, while the great oceans hold nearly everything else. The comparison is remarkably accurate. One of the finest examples is the Coma Cluster. Containing more than 1,000 known galaxies, this enormous system lies over 300 million light-years away. Visible light photographs reveal countless beautiful galaxies scattered through space, but overlay an X-ray image, and an entirely different universe appears. A gigantic glowing cloud surrounds every one of them. The galaxies themselves become islands inside an ocean that had remained invisible for billions of years. These cosmic seas are far from calm. Although their motions unfold across immense spans of time, enormous waves ripple through them continuously. When galaxy clusters collide, Shockwaves spread across the plasma, much like ripples racing across the surface of a lake after a stone falls into the water. Some of these waves stretch millions of light years from one end to the other. Yet, because everything moves so slowly on human timescales, they appear almost frozen. A wave that would cross Earth's oceans in days may require hundreds of millions of years to travel across a galaxy cluster. Patience becomes part of the physics. These invisible oceans also influence the galaxies drifting within them. As galaxies move through the hot plasma, they experience something rather like wind resistance. Astronomers call this ram pressure stripping. Imagine riding a bicycle through heavy rain. The faster you travel, the more strongly the rain pushes against you. Now imagine a galaxy speeding through an invisible ocean. Its own clouds of hydrogen feel pressure from the surrounding plasma. Gradually, some of that precious gas is swept away behind it, like a long, shimmering tail. Without fresh hydrogen, future star formation slows. Entire galaxies quietly grow older because of the ocean surrounding them. Even here, the sea shapes life. Sometimes the plasma cools, tiny regions become denser, clouds begin drifting back toward galaxies, fresh material becomes available for future generations of stars. The ocean both removes and returns. Like Earth's tides endlessly reshaping distant shores, these hidden seas also preserve another remarkable secret. Their temperature reveals the tremendous influence of dark matter. Without the gravity supplied by enormous dark matter halos, this incredibly hot gas would simply escape into intergalactic space. Instead, it remains trapped. Invisible gravity forms the basin. Invisible plasma fills it. Galaxies quietly drift inside both. The universe builds oceans using ingredients almost entirely beyond ordinary sight. There is something profoundly beautiful about that. Human beings often mistake visibility for importance. We celebrate mountains because we can see them. We admire stars because they shine. Yet some of nature's greatest structures remain hidden. The oceans above every galaxy, the dark matter beneath every cluster, the magnetic fields quietly threading through space. Reality extends far beyond what our eyes alone can perceive. Perhaps our own lives contain similar invisible oceans, quiet friendships supporting us without asking for recognition, gentle habits shaping each day, moments of kindness whose influence spreads farther than we ever realize. The strongest currents are not always the loudest. The universe whispers this lesson again and again. Its largest oceans make no sound. Their waves never crash upon a shore. No moonlight glitters across their surface. Yet they patiently cradle entire galaxies for billions of years. Every island of stars drifts because these hidden seas continue holding them. Every future generation of suns depends, in some small way, upon oceans almost no living creature will ever directly witness. And somewhere tonight, far beyond the familiar glow of the Milky Way, an invisible sea of plasma continues stretching across millions of light years. Gentle waves rolling silently between thousands of galaxies. Its ancient currents flowing beneath constellations no human eye can ever fully see. Quietly reminding the universe that even the greatest oceans do not always sparkle beneath the light. 9. The ancient echoes still crossing space. Some whispers from the young universe are still traveling toward us today, after nearly 14 billion years of silence. Imagine standing in a vast mountain valley just after sunset. You call out only once. Your voice disappears into the distance. For a brief moment, everything becomes perfectly still. Then, several seconds later, the echo quietly returns. Not because your voice has survived unchanged, but because the landscape patiently carried it back to you. The universe is filled with echoes like these, not echoes lasting seconds, but echoes traveling for almost 14 billion years, long before the Earth existed, before the sun was born. Before the Milky Way had settled into its graceful spiral shape, the young universe released whispers that are still crossing space tonight. They have traveled farther than any star. They are older than every galaxy we can see. And at this very moment, some of those ancient messengers are gently passing through your body without making the slightest sound. Tonight, we'll follow these extraordinary echoes across the history of the cosmos. We'll discover how the universe preserved its earliest memories, why silence can carry stories longer than light from any single star, and how every direction in the night sky quietly sings the same ancient lullaby that began almost at the beginning of time. Human beings have always loved echoes. They remind us that the past is never completely gone. A footprint remains long after someone has walked away. The rings inside a tree remember seasons that disappeared centuries ago. Even distant starlight is a kind of echo, arriving long after its journey first began. The universe itself preserves memories in much the same way. Its oldest stories continue traveling through space long after the events that created them have faded into history. Perhaps the greatest of these stories is the cosmic microwave background, often called the oldest light in the universe. Yet calling it light can be slightly misleading. When it first began its journey, nearly 14 billion years ago, it was indeed visible light, bright enough that, had human eyes existed then, the young universe might have appeared to glow softly in every direction. But the universe has been expanding ever since. As space itself stretched, so did those ancient waves of light. Their wavelengths became longer. Their energy slowly diminished. Visible light gradually transformed into microwaves. The message survived. Only its voice changed. To understand why this ancient echo exists, we must travel back to a time when the universe looked nothing like the peaceful cosmos we know today. For its first few 100,000 years, the universe was astonishingly hot. Temperatures reached thousands of degrees. Electrons drifted freely. Protons wandered independently. Light itself struggled to travel very far. Every photon attempting to move across space quickly collided with another charged particle. Imagine trying to walk through an impossibly crowded festival. Every few steps, someone blocks your path. You cannot move freely. The early universe was much like that. Light existed, but it remained trapped inside an endless glowing fog. Then something remarkable happened. As the universe expanded, it gradually cooled. About 380,000 years after the Big Bang, temperatures finally dropped enough for electrons and protons to combine into neutral hydrogen atoms. Almost instantly, space became transparent. For the very first time, light could travel enormous distances without constantly being scattered. Astronomers sometimes call this moment the universe's first release of light. It was not the birth of light itself. Rather, it was the moment light finally became free. Those very first liberated photons are still traveling today. Every second, countless ancient particles from that distant era pass quietly through Earth, through mountains, through oceans, through our own bodies. They have been crossing the cosmos for nearly 14 billion years without ever stopping to rest. Unlike the light from nearby stars, these ancient messengers do not come from one particular direction. They arrive from everywhere. No matter where astronomers point their instruments, they detect the same faint microwave glow. It surrounds our entire planet, our entire galaxy. Indeed, every galaxy in the observable universe. It is rather like standing inside an enormous cathedral where every wall softly reflects the same ancient melody. The song has never truly ended. It has simply become quieter with time. When scientists first discovered this faint background radiation in 1965, the discovery happened almost by accident. Two radio astronomers, Arno Penzias and Robert Wilson, were carefully testing a sensitive antenna. No matter where they pointed it, a mysterious hiss remained. They checked their equipment. They examined nearby radio interference. They even cleaned nesting pigeons and their droppings from inside the antenna, wondering whether they had somehow caused the persistent noise. The hiss refused to disappear. Eventually, they realized they were listening to something unimaginably older than any ordinary radio signal. They had accidentally detected the oldest surviving light in existence. The universe itself was quietly whispering. That faint microwave glow has since become one of the greatest treasures in modern cosmology. Tiny variations within it, differences of only a few millionths of a degree, reveal the earliest seeds from which every future galaxy would eventually grow. The smooth glow was never perfectly smooth. Almost invisible ripples already existed. Gravity patiently amplified those tiny irregularities over billions of years. Eventually, they became galaxy clusters, stars, planets, life. Everything began with differences so delicate that only the most sensitive instruments can measure them today. It is astonishing to realize that the largest structures in the universe owe their existence to fluctuations almost too small to imagine. The universe never needed dramatic beginnings, only patient ones. These ancient echoes have another remarkable quality. They remind us that the observable universe possesses a shared memory. Every civilization that might someday arise in another distant galaxy would observe nearly the same cosmic background. Their measurements might differ slightly because of their own motion through space. But the ancient glow itself belongs to everyone. It is the oldest common photograph the cosmos still carries, a family portrait preserved across billions of years. Sometimes, astronomers describe the cosmic microwave background as the baby picture of the universe. The comparison feels wonderfully appropriate. When we look at photographs of ourselves as infants, we see someone almost unrecognizable. The face is different, the body is smaller, yet something essential remains. The adult was already hidden inside the child. In much the same way, every galaxy decorating tonight's sky was already quietly present inside those tiny fluctuations, not yet visible, not yet formed, but waiting. There is something deeply comforting about that thought. The universe has never truly forgotten where it came from. Its oldest memories continue traveling alongside us every moment of every day, even in complete darkness, even between galaxies, even after nearly 14 billion years. The first whispers still survive. Perhaps memory itself is one of nature's greatest forms of endurance. Stars explode, galaxies merge, planets come and go. Yet light keeps traveling, patiently carrying stories no one has finished hearing. The night sky becomes more than a collection of distant objects. It becomes a conversation still unfolding. Every photon arriving tonight began its journey in a different chapter of cosmic history. Some left nearby stars only years ago. Others departed distant galaxies millions of years in the past. And the oldest among them have been traveling almost since time itself first learned how to shine. And somewhere above us tonight, ancient microwaves continue drifting silently through the darkness, crossing oceans of space that did not yet contain galaxies when their journey began, passing unnoticed through worlds that would have seemed impossible when they first set out, still carrying the quiet echoes of a newborn universe, patiently reminding anyone willing to listen that some whispers never truly fade. 10. The bridges that hold galaxies together. Invisible bridges stretch across the universe, quietly guiding galaxies toward one another over billions of years. Imagine walking through a dense forest just before dawn. The trees appear scattered at random. Each stands quietly in its own place. At first glance, there seems to be no connection between them. Then the morning mist begins to lift. Slowly, you notice narrow trails winding between the trunks. Some paths are barely visible, others stretch farther than you can see. Animals have followed them for generations, seeds have traveled along them. Entire forests have quietly depended upon these hidden roots for centuries. Without the trails, the forest would not truly function as one living place. The universe has pathways like these, only they are larger than imagination itself. Invisible bridges stretch across millions of light years, linking galaxy to galaxy, cluster to cluster, until nearly the entire observable universe becomes one enormous connected network. No traveler has ever crossed these bridges. No telescope captures them directly in ordinary light. Yet, they quietly guide the journeys of galaxies across billions of years. Tonight, we'll follow these hidden pathways through the deep cosmos. We'll discover why galaxies rarely grow alone, how invisible bridges became the framework of the cosmic web, and why some of the universe's greatest structures exist almost entirely beyond the reach of human sight. When people first began mapping the stars, they naturally imagined the universe as a collection of isolated islands. One galaxy here, another galaxy there, each separated by enormous emptiness. The spaces between them appeared almost meaningless, but nature rarely wastes space. As astronomical surveys became more powerful, scientists noticed something curious. Galaxies were not distributed randomly. Instead, they gathered into long chains. Those chains connected enormous clusters. The clusters formed intersections. Between them stretched vast empty regions called cosmic voids. From a great enough distance, the entire universe resembled an unimaginably delicate spider's web, or perhaps the branching roots of an ancient tree. This enormous network became known as the cosmic web. Yet the galaxies themselves account for only a tiny fraction of its true structure. Most of the bridges are invisible. Their hidden foundations are made primarily of dark matter. As we explored earlier, dark matter neither shines nor reflects light. But gravity does not require light. Dark matter quietly gathers into enormous filaments stretching across space. These filaments become invisible highways. Ordinary matter slowly follows. Hydrogen drifts inward. Galaxies gradually emerge along the same routes. Imagine rainwater flowing across a mountainside. You cannot always see the tiny valleys guiding its movement. Yet every stream eventually discovers the same channels carved into the landscape. The universe behaves similarly. Gravity shapes invisible valleys. Matter simply follows them. Over billions of years, those gentle flows become galaxies. Then, galaxy groups. Then, immense clusters connected by bridges millions of light years long. Computer simulations have revealed these astonishing structures with remarkable clarity. When physicists begin with the tiny fluctuations left behind by the early universe and allow gravity to work for billions of simulated years, something beautiful emerges. Long filaments gradually appear. Dense intersections develop. Immense empty voids expand between them. The final pattern looks astonishingly similar to what telescopes actually observe today. Nature seems to have written the same design into both mathematics and reality. One of the most fascinating aspects of these bridges is that they never truly stop working. Even today, galaxies continue flowing along them, very slowly, almost imperceptibly. Entire galaxies drift toward larger structures. Hydrogen gas streams through these invisible corridors. Small galaxies fall into larger ones. Clusters gradually become richer over cosmic time. The bridges are not frozen monuments. They remain active rivers of gravity. Imagine watching a river from high above. The water appears calm, almost motionless. Yet beneath the surface, countless tiny currents continue carrying leaves, branches, and nutrients toward the sea. The cosmic web behaves in much the same way. Its motion simply unfolds across billions rather than seconds. Astronomers have even detected evidence of ordinary gas stretching between galaxies along these bridges. These delicate filaments contain diffuse hydrogen, only a few atoms per cubic meter. That sounds astonishingly empty. And it is. Earth's atmosphere contains roughly 10 quintillion molecules inside the same volume. Yet, because the bridges extend across millions of light years, their total mass becomes enormous. Quiet rivers of hydrogen continuously feed growing galaxies. Without this slow supply of fresh material, many galaxies would eventually exhaust the gas needed to create new stars. In a very real sense, the bridges keep galaxies alive. One remarkable example lies between the Abell 222 and Abell 223 galaxy clusters. Using X-ray observations, astronomers detected an enormous filament of extremely hot gas connecting the two clusters. The bridge stretches across tens of millions of light years. Although almost invisible, it contains enough matter to influence the evolution of everything surrounding it. Nature had quietly built an intergalactic connection long before humanity learned to observe it. Other discoveries suggest that some of these bridges also contain magnetic fields, weak beyond anything we experience on Earth, yet spread across incomprehensible distances. These magnetic threads may help guide charged particles through intergalactic space, quietly linking environments separated by millions of light years. Even the invisible forces themselves appear connected. The longer astronomers study the cosmic web, the more it resembles a living system. Not alive in the biological sense, but organized, responsive, interconnected. Every galaxy influences its surroundings. Every bridge transfers matter. Every cluster reshapes the nearby flow. Nothing exists entirely alone. There is another beautiful consequence of these invisible pathways. They help explain why galaxies often appear where they do. Massive galaxies almost always occupy the crowded intersections where several filaments meet. Smaller galaxies line the connecting bridges. Meanwhile, the enormous voids remain sparsely populated. It resembles the growth of great cities. Large metropolitan centers develop where many roads intersect. Smaller towns flourish along highways. Remote wilderness survives far from every major route. The architecture feels surprisingly familiar. Only the scale has become cosmic. Perhaps this is one reason the universe seems so harmonious despite its enormous size. Order quietly emerges from simple rules. Gravity never announces its plans. It merely continues pulling gently. Year after year, million after million years. Eventually, elegance appears. The greatest structures in existence arise without anyone directing them. There is something profoundly comforting in that thought. Our own lives are shaped by invisible bridges as well. Conversations that change our future. Teachers we almost forgot. Books discovered at exactly the right moment. Acts of kindness passed from one person to another. Rarely do we notice these quiet connections while they are forming. Only years later do we recognize that invisible paths were guiding us all along. The universe seems to whisper the same lesson. Nothing truly grows in isolation. Even the loneliest galaxy receives unseen currents from the larger cosmos. Every cluster depends upon bridges extending far beyond its own borders. Every future generation of stars begins with hydrogen carried patiently through invisible roads built near the dawn of time. The connections matter just as much as the destinations. And somewhere tonight, far beyond the familiar spiral of the Milky Way, an invisible bridge of dark matter and ancient hydrogen continues stretching across millions of light years, quietly carrying fresh material toward galaxies that have not yet finished growing, linking distant clusters into one immense cosmic tapestry, patiently reminding the universe that its greatest distances have always been connected by pathways no eye can truly see. 11. The places where tomorrow's galaxies already exist. Some quiet clouds drifting through space today may already contain the hidden beginnings of galaxies that won't fully appear for billions of years. Imagine planting a single acorn in an open field. For weeks, nothing seems to happen. The ground remains quiet. The wind continues blowing across empty grass. Anyone walking past might believe the little seed has failed. But beneath the soil, invisible changes have already begun. Tiny roots slowly search for water. The first fragile stem quietly gathers strength. The future forest already exists, long before anyone can see a single branch reaching toward the sky. The universe works with the same extraordinary patience. Some of the galaxies that will one day shine across the distant cosmos may already exist today. Not as graceful spirals filled with billions of stars, but as enormous, quiet clouds of gas and dark matter drifting almost unnoticed through space. To us, they appear unfinished, incomplete, almost empty. Yet hidden within these silent regions are tomorrow's galaxies, patiently waiting for gravity to complete a story that may take billions of years to unfold. Tonight, we'll journey to these cosmic nurseries of the future. We'll discover how galaxies are born long before they become visible, why the universe is always building tomorrow while we admire today, and how some of the quietest places in existence may already contain civilizations of stars that no telescope will fully witness for ages to come. Human beings naturally think of creation as a single event. A building is finished when the final stone is placed. A painting is complete when the artist signs the canvas. A flower blooms almost overnight. The universe rarely works that way. Its masterpieces unfold so gradually that beginnings and endings often overlap. While one galaxy quietly grows old, another has only just begun gathering the material needed to exist. Creation never truly pauses. It simply moves at a pace that exceeds every human calendar. To understand these future galaxies, we must first remember that galaxies are not built from stars alone. Long before the first sun ignites, gravity begins collecting enormous reservoirs of hydrogen gas. These clouds are astonishingly large. Some stretch hundreds of thousands of light years across. Others extend even farther, blending gently into the vast intergalactic medium. At first glance, they seem almost empty. The gas is extraordinarily thin. In many regions, only a handful of atoms occupy the same volume that Earth's atmosphere fills with trillions upon trillions of molecules. If we could somehow drift through one of these clouds, we might hardly notice it at all. Yet gravity notices everything. Even the slightest excess of matter slowly begins attracting more. A region just a little denser than its surroundings quietly becomes a gathering place. Hydrogen drifts inward. Dark matter deepens the invisible gravitational well. Very slowly, the cloud begins changing, not dramatically, not quickly, but relentlessly. It is rather like watching morning frost form upon a window. For many minutes, nothing appears different. Then tiny crystals suddenly become visible. Soon intricate patterns spread across the glass. The beauty seems to arrive, all at once. In reality, it had been growing patiently the entire time. Galaxies emerge in much the same way. Modern astronomy has revealed enormous protogalactic clouds scattered throughout the distant universe. These are not fully formed galaxies. Instead, they represent early stages of assembly. Some contain vast quantities of hydrogen waiting to collapse into future stars. Others already possess small pockets where the first generations of stars have quietly begun illuminating their surroundings. The architecture exists before the city. One remarkable discovery involves objects known as Lyman alpha blobs. These enormous clouds of glowing hydrogen can stretch hundreds of thousands of light years across. Some appear to represent galaxies, or even groups of galaxies, in the earliest stages of formation. Their exact nature remains an active area of research, but many astronomers believe they offer a glimpse of cosmic construction sites billions of years before completion. Rather than seeing finished galaxies, we are witnessing foundations. The James Webb Space Telescope has added even more fascinating pieces to this puzzle. Its extraordinary infrared vision allows astronomers to study galaxies that existed when the universe was only a few 100 million years old. Many appear surprisingly mature. Others reveal systems still gathering material through long filaments of gas. Some seem caught halfway between cloud and galaxy. It is almost like opening a photo album documenting childhood, adolescence, and adulthood simultaneously. The universe has preserved every stage of its own growth. Perhaps the most beautiful aspect of these future galaxies is that they never develop alone. As we have explored throughout our journey, invisible filaments of dark matter connect nearly every large structure in the observable universe. Hydrogen flows gently along these cosmic bridges. Fresh material continuously arrives. Imagine rivers quietly feeding a growing lake. The lake expands not because it suddenly appears, but because patient streams continue nourishing it year after year. Galaxies experience something remarkably similar. Even today, many continue drawing fresh hydrogen from the intergalactic medium. That gas will eventually cool, clouds will collapse, new stars will ignite. Entire stellar neighborhoods that do not yet exist are already beginning their journey toward existence. In a sense, the future is always flowing into the present. Computer simulations illustrate this process with breathtaking elegance. When scientists allow gravity, dark matter, and ordinary gas to evolve over billions of years, galaxies do not simply appear. They emerge naturally. Small structures merge into larger ones. Fresh gas falls inward. Star formation rises and falls like gentle breathing. Some galaxies remain quiet for long periods before suddenly awakening as new material arrives. Others slowly continue growing for nearly the entire age of the universe. There is no single moment when a galaxy becomes complete. It is always becoming. Our own Milky Way reminds us of this truth. Although more than 13 billion years old, it has not stopped growing. Small dwarf galaxies continue falling toward it. Fresh clouds of hydrogen still drift inward. New stars continue forming every year. The galaxy surrounding our solar system is not a finished object preserved inside a museum. It remains a living structure. The Milky Way of 5 billion years from now will not be exactly the Milky Way we know tonight. Even ancient galaxies possess tomorrows. This perspective changes how we think about time itself. We often imagine the universe as something ancient, whose greatest days lie behind it. Certainly, many remarkable events occurred billions of years ago. The first stars, the first galaxies, the first heavy elements. Yet, creation has never ended. Some of the most beautiful galaxies the universe will ever produce may not yet fully exist. Entire constellations of future suns remain hidden inside clouds that still appear dark. Worlds capable of supporting oceans, mountains, perhaps even curious civilizations, may already be quietly assembling from invisible streams of hydrogen. The cosmos is still writing new chapters. There is something profoundly hopeful about that. We sometimes worry that beauty belongs only to the past. The universe gently disagrees. Its greatest masterpiece has never been finished. Every passing billion years adds new details, new stars, new galaxies, new possibilities. Perhaps our own lives unfold according to the same quiet rhythm. We often judge ourselves by what is already visible. Achievements completed, dreams accomplished, paths clearly defined. Nature reminds us that some of the most important growth happens long before anyone notices. Invisible roots, quiet foundations, patient preparation. The future often begins while everything still appears unchanged. The galaxies of tomorrow are already being built. Not with noise, not with urgency, but with the same gentle persistence that has guided the universe since its earliest dawn. And somewhere tonight, far beyond the edge of every familiar constellation, a vast cloud of ancient hydrogen continues drifting through the darkness, its invisible halo of dark matter quietly gathering more material with every passing million years. Its first generations of stars not yet fully born, already carrying within it the hidden promise of a magnificent galaxy. One that countless future civilizations may someday look upon with wonder, never realizing that tonight it still exists only as tomorrow's dream. 12. The pattern that never stopped growing. The universe isn't simply expanding, it's patiently weaving one enormous cosmic masterpiece that has never stopped growing since the first moments of time. Imagine watching someone weave a great tapestry. At first, there is almost nothing, only a few delicate threads stretched across an empty wooden frame. If you walked away after a few minutes, you might believe nothing meaningful was being created. But return years later, the threads have become forests, mountains, rivers, entire worlds stitched together into one breathtaking work of art. No single thread explains the whole picture. Only time reveals the masterpiece. The universe may be creating something remarkably similar. We often hear that the universe is expanding. Galaxies drift farther apart. Space itself slowly stretches. But expansion is only part of the story. While everything grows farther apart on the largest scales, gravity quietly continues weaving galaxies together into one enormous cosmic pattern. For nearly 14 billion years, invisible threads have connected stars, galaxies, clusters, and vast oceans of intergalactic gas into a design so immense that no single observer could ever see it all at once. Every chapter of our journey tonight has been one thread within that tapestry. The lonely stars wandering between galaxies, the invisible rivers feeding newborn suns, the hidden oceans surrounding galaxy clusters, the ancient echoes still crossing the darkness, the bridges joining distant galaxies, the quiet clouds preparing tomorrow's galaxies. None of them exist separately. Together they form one story, one pattern, one masterpiece that has never stopped growing. Tonight, for our final journey, we'll step back farther than ever before, far enough to glimpse the universe not as scattered objects, but as one living work of cosmic art still being woven across the endless fabric of time. Human beings naturally search for patterns. We find familiar shapes among the stars. We recognize faces in clouds. We notice repeating rhythms in music long before understanding the notes themselves. Our minds seem almost designed to connect separate pieces into meaningful wholes. Perhaps that instinct exists because nature itself is built upon patterns. A snowflake grows according to elegant symmetry. The branches of a tree resemble the roots beneath the soil. River systems echo the branching vessels inside our own lungs. Again and again, simple rules create astonishing beauty. The universe follows the same quiet principle. Its largest structures emerged not from chaos, but from countless small events gently working together across unimaginable spans of time. When astronomers first mapped only a handful of nearby galaxies, the cosmos appeared almost random. Here was one spiral galaxy. Far away floated another. The darkness between them seemed empty, meaningless. But as telescopes grew more powerful, and galaxy surveys expanded across billions of light years, a hidden picture slowly emerged. The galaxies were not scattered carelessly. They gathered into graceful filaments. Those filaments met inside enormous galaxy clusters. Between them stretched vast cosmic voids. The entire observable universe resembled lace woven across the darkness, or perhaps the delicate network of neurons inside a living brain. Some scientists have even remarked upon the remarkable visual similarities between the cosmic web and biological networks. Although the underlying physics is entirely different, both reveal a profound truth. Simple interactions repeated countless times often create astonishing complexity. No master artist painted each galaxy individually. Gravity simply continued working, patiently, faithfully, for billions of years. As we explored earlier, everything began with fluctuations almost too tiny to imagine, minute differences in density left behind shortly after the Big Bang. Those tiny irregularities became the first stitches. Gravity slowly pulled matter inward. Dark matter created invisible scaffolding. Hydrogen followed. The first stars ignited. Galaxies appeared. Galaxy groups gathered. Clusters emerged. Filaments stretched farther. Every new generation inherited the work completed before it. The universe never discarded an earlier chapter. It simply continued building upon it. There is something deeply beautiful about that. Nothing was wasted. The hydrogen forged during the earliest moments of cosmic history still fuels stars today. Heavy elements created inside ancient supernovae became future planets. Dust from dying suns formed new generations of stars. Even galaxies themselves continue merging into larger structures. The universe does not erase its past. It transforms it. Our own Milky Way is living proof. Every star overhead carries a different history. Some formed nearly 13 billion years ago. Others were born only millions of years ago. Some arrived from dwarf galaxies long since absorbed into the Milky Way. Streams of ancient stars still circle our galaxy, preserving memories of mergers completed billions of years in the past. The galaxy above us tonight is not a snapshot. It is an archive, a living museum whose oldest exhibits continue sharing space with its newest arrivals. Perhaps that is why astronomy often feels less like studying distant objects and more like reading an unfinished story. Every observation becomes another page. The James Webb Space Telescope continues revealing galaxies that challenge previous ideas. Future observatories will undoubtedly discover structures we have not yet imagined. The pattern continues expanding even within human knowledge. The universe is still surprising the very creatures attempting to understand it, and perhaps it always will. One of the most comforting realizations in modern cosmology is that the universe has never truly stopped creating. Stars continue forming. Galaxies continue growing. Planets continue assembling. Even now, somewhere beyond the edge of our observable horizon, regions of space forever hidden from us continue following the same quiet laws. The masterpiece extends beyond every map humanity can ever draw. There is always another thread, another chapter, another distant sunrise waiting where no telescope can yet see. Sometimes people ask whether the universe has a destination. Will the weaving someday end? No one knows with certainty. The expansion continues. Stars will eventually grow rarer. Galaxies will slowly change. The distant future may become quieter than anything we can presently imagine. Yet even then, the pattern already woven will remain one of the greatest creations reality has ever known. Every generation of stars, every drifting galaxy, every invisible bridge, every ancient photon will forever remain part of that immense design. Perhaps that offers a gentle lesson for us as well. Our own lives often feel like scattered moments, a conversation here, a quiet evening there, a forgotten kindness offered years ago. Rarely do we recognize the pattern while we are living inside it. Only later do we see how one decision quietly led to another, how friendships connected distant chapters, how small moments became the strongest threads in our own stories. The universe seems to whisper that growth rarely announces itself. Masterpieces are seldom completed in a single day. Instead, they emerge patiently. One thread, one star, one galaxy, one lifetime at a time. And so, as our quiet journey through the cosmos comes gently to its close, the night sky above us feels a little different. Not because the stars have changed, but because we have learned to see the invisible threads between them. The galaxies no longer drift alone. The darkness no longer feels empty. Every distant light belongs to something far larger than itself. One endless pattern, still growing, still unfolding, still quietly weaving beauty across the fabric of space and time. And somewhere beyond every constellation, beyond every galaxy we will ever name, beyond even the oldest light still crossing the universe, the cosmic tapestry continues expanding with extraordinary patience. New stars quietly joining ancient ones, invisible bridges carrying tomorrow toward today, gravity adding one more delicate thread to a masterpiece that began almost 14 billion years ago and has never once stopped growing. If these gentle explorations help you end your evening with a little more wonder, consider subscribing, and I'll be here for our next quiet journey through the universe.